All right, so welcome to Eureka Math Squared. This is grade 6, module 4, lesson 13, and we're hanging out with the distributive property. Yeah, folks, this is all about the distributive property. So we'll begin on page 159, one of my favorite properties, and it really is what it says, right? It says to distribute, and that's what we're going to be doing. So this page likes to, I suppose, model the distributive property. You can see that I have a rectangle here and a rectangle here, and then those same rectangles are hanging out over here. So here's how it works, right? So if I were to find an area for this guy, an area for this guy, right? A little length times width, a little length times width, and those two areas combined should give me the same area as this guy, right? So that makes sense. Let's find this one first. So this would be, since we're multiplying the length times the width, let me use parentheses, big fan of parentheses, right? So this would be a little 56 units squared, right? Little 56 units squared. The other guy, if I were to substitute, I need that 13 times a 7. Right, so let me do a little 13 times 7 in this corner right over here. So that's a little 21, right? Little 7, 8, 9, so a little 91 units squared. Now, if I were to combine those for the big guy, add them up, watch this, right? So I add them up and I get that 7, that 14, and I should have 147 units squared. All right, so let's work with that distributive property. Okay, so let's see here. Now, if I were to say to you, okay, now how do I find the area of this guy here? You would tell me 7 times the 8, right? And over here, since they share the same length, right, this guy here would be a 7 times 13, right? So you following me here a little bit? So I would have so if I wanted to find the total area, I would do with a 7 times the 8, right? And I would multiply those two. That's this guy here. And I would add to that the 7 times the 13, right? And that would give me the area for the whole thing. But notice they have something in common. They have that 7 in common. So if I were to pull that out, I could also say, hey, wait a minute. Couldn't I also find the area of this guy by simply combining these two values and finding one great long width by saying, hey, what's that 13 plus that 8, right? And I wind up with 21. So can't I just make a new rectangle and say, hey, this one's 21 units and this is a 7 units, right? Don't you get the same area? And if so, sorry, that's so messy. Um, why don't I just write it that way? A little 13 plus the 8. There's the 8, there's the 13, add them up. And you wind up with the same thing. Watch, if I were to add these here, right? So I get my 21 times my 7 equals my area. So go ahead, take that 21, multiply it by 7. There's my 7, there's my 14. There it is, right? So area equals 147 units squared. But what's the big deal? What's the purpose? Well, check it out. This guy here, this guy here, two equivalent expressions. Now, the distributive property basically states, hey, I could take that 21, I can split it up into however many parts I want. Let's say I take that 7 and any sum of 21, right? Any sum. So let's say I do a 5 and a 5 and a 10 plus a 1. That gives me my 21. And if I distribute that 7 to each of these guys using multiplication, in other words, take the 7, multiply it by the 5, right? So I do 7 times 5, right? Added to that, the 7 times that 5. This is the distributive property. I'm distributing the 7 to all these other values, right? Times the 5 plus a 7 times a 10. And then there's a 1 left over. Again, I can use any combination I want, plus a 7 times the 1. I'm going to get that 147. Let's see. So 35 plus another 35 plus a 70 and plus a 7. Let's see. So 35 and 35 gives you 70, right? Add that other 70, then add that 7. What do you get? 147. So the distributive property So that's modeling the distributive property. But in practice, it goes a lot faster. So let's just put, I guess, work another model. I wasn't going to do this model here, but that's okay. We'll do it. Okay, so here we go. So if I were to find the area of just this guy, right, what would I multiply? I would multiply the 3 times the 6, right? And what about this guy? Well, he shares this same width, this 3 units. So it would be a 2x times 3, right? That guy is 2x, so it's 2x times 3. Let me get rid of the x in here. I'm going to use parentheses, right? I should be using parentheses for multiplication. There you go. So that area is going to be a 3 times a 6, right? Added to that, that's this guy. Added to that, the area of this guy, which is a 2x times 3. Okay? Now, if I combine things out here, this guy, that gives me an 18. Added to these guys, that gives me a 6x, right? And there we go. All right, so I have that, which is the same as saying take 3 multiplied by 6, added to that, 2x times 3. Okay? Another way I can write it is, let me just say, hey, what about that 3? Let me pull that 3 out and then make one long length of the 6 plus the 2x. There it is, right? 6 plus the 2x. Now, if I distribute that 3, watch what happens here. Here's the magic, right? Using multiplication, 3 times 6 gives me 18, right? Plus, there's that plus, right? You can do distributive property with subtraction, but this one's a plus. Distribute that 3 to this guy using multiplication. In other words, 3 times 2x, and you're going to get 6x. Look familiar? Check it out. There's this guy. There's this guy. Okay. Now, if we were to fill in some things down here, right, down here, there we go. We have it. We have, let's see, the 6 times the 3, right, and the 3 times the 2x, right? There you go. Okay, so there's the 3 being distributed, the 3 times 6, there it is, and the 3 being distributed to the 2x, the 3 times the 2x. Okay? All right, moving along. Let's see, what else did I check off to work? These get more fun when you don't have all the drawings, and like in here, right, hanging out in these problems. So this is page 163. Okay, and all I want to do is just use the distributive property here. So I'm just going to distribute. Now, I was taught to always use arrows, distribute like this, but notice something. This is distributive property with subtraction. So what I want here is take that 3x and multiply it by, 3/4, and multiply it, distribute to that 3x. So it looks like this, 3/4 times that x, just like that. And there's that minus, right? There's that minus right there. And then take the 3/4 and distribute to the 12, which means I want 3/4 times 12. Okay, but I'm not quite done yet. Now I actually have to do the multiplication. So 3/4 times x is 3/4 x, right? You try to use the fewest amount of symbols possible. Minus, there's the minus. Now I've got this guy, 3/4 times 12. Well, I can multiply that, right? Something with the bottom with something with the top. I can simplify, get a 3 there, and I wind up with 9. There you go. Okay. This guy, that's 7. I like the 7 being on the other side there, so I'm just going to toss him over there. I don't know what he's doing over there. I'm going to do that. Okay, now I can distribute that 7 to the 2, which means it's 7 times 2. There's a minus again, so I'm going to put a big old minus. Now I'm going to distribute the 7 to the 3n, which means it's 7 times 3n. And now I can do my little multiplication, so that becomes a 14 minus, right, there's my minus right there. And then this guy here, which is 21n, oops, right, which is 21n, like that, right, because this becomes a 7 times a 3 times an n, so that gives you your 21n. All right, now you can get into some decimal stuff, sure, but it's the same thing. You just take that 18, distribute it to the 0.5a, like that. Well, this is addition, so now you switch over to addition. Take that 18 and distribute it to the 0.5b. So 18 times 0.5b. Now all you have to do is pull off the multiplication. Now this becomes 3 factors here. So the 18 is a factor, the 0.5 is a factor, the a is a factor. Might as well just blow this up a little bit, right? Little 18's factor, little 5 is a factor, expand it out, right? Just expand it out. Well, this is half of 18, which is 9, so that's 9a, plus half of 18 again, which is 9, right? Don't forget the b. There it is. So that guy's done. Okay? Now, if you distribute the 3 values, it's the same thing, right? Just keep on going. All right? You wind up with 3 different terms, right? Because here's a term here, here's a term here, right? Let's see what else I got for you here. Do I have anything else? Oh, the exit ticket. Oh, okay, right, 2 expressions. This is page 165. Sure. How about I do the 1.5 times the m, that's for that area. And for this one is the 1.5 times the 2. All we have to do is write that out, right? Area is length times width. So I can either do the 1.5, take this guy, and multiply the sum of those, right? M plus the 2. Okay, you can add those up like that. Or you can do what I did in here, right? You can use these and say, hey, area is going to be the 1.5 times the m plus the 1.5 times the 2. There you go. Okay. And lastly, how about we just distribute this guy? Why not? So this guy here is a 4 times the 2b, so I'm just going to write that out. 4 times the 2b minus, right? There's a minus. Distribute the 4 to the 5. So that's just 4 times 5. Well, that one's not bad, but this one I want to expand that a little bit more. I'm just going to keep on going. Break it up into all the factors. Why not? This simply becomes 20. So I just combine these guys, and I want it with 8 times b. 8 times b, sorry, minus 20. Distributive property. Okay, so distributive property is all about multiplication. It's kind of cool. So I hope you enjoyed that. All right, thanks so much. Take care. Bye-bye.